So let's do this next two problems. So this one we have -1/2 cosine of 2 pi x plus pi over 4. So you can see that we have an amplitude change that's being compressed. We got a flip, we got a period change, and we also have a phase shift. So let's first start off by rewriting this guy. So you got this -1/2 cosine. So remember, what we want to do is isolate that x. So we're going to pull out that 2 pi. And then the answer, you get an x plus, and remember that pi over 4, what we're doing with that is just dividing it by 2 pi. So you got this 2 pi x. The pi's cancel out, and you got this, so the pi's go away. You got 4 times 2, which gives me 1/8. Okay. All right, so now let's go ahead and pinpoint everything that we have so far. So we can see that we have the new period. It's going to be 2 pi over the absolute value of b. You got 2 pi over b, which in this case is still 2 pi. And it's 1. So my new period is 1. So it's going to complete one full cycle in just from 0 to 1. Okay, so if you kind of think about it, let's go ahead and just do a little sketch. It's going to complete one whole cycle from 0 to 1, which is nice because we don't have to deal with the pi's. We got the 3 points in the between, and it's going to look something like this. So we kind of have the idea of what it's going to look like. Right now, luckily for us, it's not just that easy because now we still got that 1/8, so that crazy 1/8 outside. Oops. So we got this 1/8 out here that we got to take care of. So that's going to be the phase shift. So the phase shift is going to be 1/8, and since it's positive, it's going to be to the left. So in other words, imagine that I'm subtracting a 1/8. So subtract 1/8. So it's always the opposite of whatever this does. Okay. So now let's go ahead and figure this out. So everything's going to be moving over 1/8. So now my starting point, which was originally 0, I'm going to move that 0 over 1/8 over. That's going to give me -1/8. And now my ending point was 1. I'm going to subtract 1/8. It's going to be 7 over 8. So this graph, let me just draw the x-axis. Let's just write the x. My starting point is going to be at -1/8. And my ending point is going to be at 7/8. Okay, now we got to find the points in between. Let me color them in red. So we got to figure out what these guys are. So all we got to do is just find the midpoint. So it's going to be 7/8 plus -1/8 divided by 2. So this gives me 6 over 8 divided by 2, which gives me 6 over 16, which is going to give me, reducing this divided by 2, you're going to get 3 over 4. No, 3 over 8. Okay. All right. Oh, wrong side. 3/8 right here. Okay. Now let's look at this other midpoint. So this guy right here. So we're going to take -1/8. I'm going to add 3/8 and divide it by 2. So this is going to give me 2/8 over 2, which gives me 2 over 16, which gives me 1 over 8. And then finally do the middle part, this guy right here. So that's going to give me 3/8 plus 7/8 divided by 2. This gives me 10/8 over 2, or 10 over 16, which gives me 5/8. Okay. And I always like drawing the y-axis afterwards because you can see, oh, the y-axis should be somewhere between the -1/8 and the 1/8. So the y-axis should be right here. So my cosine curve, after everything has been shifted over, the cosine starts at 1. Here's -1, here's 1. So cosine starts at 1. Then at 1/8, I'm going to go down to 0. Then at 3/8 is -1, 0, 1. So it looks something that looks like this. So that's what the cosine curve looks like. Okay. So all of this was for this small thing. Okay. Now let's look at the -1/2. All right. Oops. So now the -1/2, basically what it's going to do is going to shrink the amplitude and flip everything over. So I'm going to switch the amplitude. Okay, so everything is basically the same. -1/8, 1/8, 3/8, 5/8, 7/8. So now I'm going to be at -1/2, so this is all shortened. And now instead of being at 1, I'm flipping it over. I'm multiplying it by 1/2 by flipping it. So now this is going to be down here. And this one's going to be at 0. This one's going to be up here, 0, and -1/2. So the graph itself is much shorter, and it looks something like that. Okay, so this would be the graph of that one above. Again, domain is still -infinity to +infinity, and the range will be from -1 to 1. No, that's just kidding. -1/2 to 1/2. Okay, so that's that guy. Yes. All right. Now let's look at this last one. All right, so again, now we have a vertical displacement, and it's going down 1 unit. Okay. So we don't have to flip, but we got a period change and we got a phase shift. So we got to fix all of that. So this is going to be 7 sine. I'm going to factor out that 3. We got x plus pi/2, and I'm going to divide this by 3. So we got 7 sine of 3x plus pi/6 minus 1. All right, so let's look at my new period. So my new period is going to be 2 pi divided by the absolute value of b. So 2 pi/3 is going to be my new period. So it's going to finish from 0 all the way to pi/3 now, 2 pi/3. It's going to start from 0. It's going to end at 2 pi/3 with obviously 3 points in between. And it's a sine curve, so it's going to go up, 0, down, 0. So it's going to look something like this. Now this pi/6, right, that's going to be my phase shift. And it's positive, so I'm going to subtract, so pi/6 to the left. So you can kind of imagine that you're subtracting pi/6. All right, so let's go ahead and do that. So my ending point, my starting point is going to be 0, and I'm going to subtract pi/6, which is going to give me negative pi/6. And then my ending point is going to be, well, now it's at 2 pi/3, and I'm going to subtract the pi/6. And I'm just going to use my calculator for this. So 2 pi/3 minus pi/6 is going to give me pi/2. So now my graph, my newly shifted graph, and because I have negative angles, I'm going to go and write it this way. So it's going to start at negative pi over 6, and it's going to end at pi over 2. And now what I got to do is figure out what my middle points are. Okay. So again, we're going to find the midpoints. So pi over 2 plus negative pi over 6 divided by 2. So I'm going to just do that. So pi over 2 and then pi over 6 divided by 2. I get pi over 6. Okay, so midway between that is just going to be pi over 6. Now I'm going to look at the negative pi over 6 and pi over 6. This one should be pretty easy, right? Because if you take negative pi over 6 and add it to pi over 6, you're going to get a 0 on the top. So this one's going to be 0. That's going to be that guy. And then we're going to look at the very last one, okay, which is basically pi over 6 plus pi over 2 and divided by 2. So I'm going to have pi over 6 plus pi over 2 divided by 2, get pi over 3. Okay, so you're going to have this line right through the middle. So here's the y-axis. Okay, and actually, as a matter of fact, just for those that have the TI-36 to see how wonderful it is, let me just show you immediately in the document camera what that kind of looks like. If you have the TI-36, one of the things that you can do is you have this nice fraction bar on the very top. So you can click on that, and then you can just put in the pi over 6 with another fraction, so pi over 6, plus put another fraction, pi over 2, and then divide this by 2. And you can see that you immediately get the pi over 6. So you don't have to be doing the least common denominator if you have this TI-36 calculator. So again, what you got to do is just take the fraction, put a fraction on the top, and then add it to your other fraction. And then the bottom one is going to be just divided by 2 because you're always finding the midpoint. So this is going to be usually the format to be able to find all of these midpoints. Just this is more an FYI for those that have this type of calculator. But let's continue. So again, now let's go ahead and kill two birds with one stone. We know that the amplitude originally was at 1 and negative 1 and 1, so the amplitude was 1. Notice that now there's an amplitude change here at 7. So this whole mess that we just did fixed this 3x plus pi over 2. So we got that down. Now this 7, notice that there's no flipping, so we're just going to shift it. It's just going to be stretched over 7 units. So now the sine curve, remember, starts at 0. So wherever my starting point is, which was negative pi over 6, that's at 0. And it's going to go up to 7, down to 0, down negative 7, and then finishing off at 0. So this is what the graph looks like. All right. So this is my sine graph shifted over and expanded or stretched up. And now finally we got to do this lovely negative 1. Okay, so we got to go ahead and work with that negative 1. And what that negative 1 is going to do is bring the graph down 1. Down 1 unit. So this graph, so here is 7, so I'm going to go down 1 to 6. Here is negative 7, so I'm going to go down 1 to negative 8. And you're going to get negative pi over 6, 0, pi over 6, pi over 3, pi over 2. So this guy is going to be shifted down 1, so now I'm at negative 1. This guy is going to be shifted down 1, so now I'm at 6. This guy goes down to negative 1. This guy was at negative 7, so I'm going to go down to negative 8. And now this guy who was at 0 is going to go down to negative 1. So you can see that the graph is going to look something like this. Okay, so this is going to be my final graph. The domain is from negative infinity to positive infinity. And my range, notice that the lowest point is at negative 8. My highest point is at positive 6. That's going to be my range. All right, cool. So we got one more problem for this unit, and then for graphing sines and cosines.